All right, we are recording.
Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine, and welcome to today's DevOps.com webinar, Pipeline Security as a Catalyst for DevSecOps. Before we get started today, I just need to go through a couple housekeeping items with you. First, please remember that this webinar is being recorded, so if you miss any or all of it, you'll be able to go back and watch it again. We will send you an email with how to access the webinar on demand, so keep an eye on your inbox for that. We are taking questions at any time during the webinar, so go ahead and submit those using the Q&A tab on your console. We'll try and get to as many as possible at the end of the event. And finally, stick around till the end because we are doing a drawing for 4 $25 Amazon gift cards. All right, so with that, I'm going to introduce you to our speakers today. Ravi Lockman is an evangelist at Harness, and Zach Conger is a senior DevOps engineer with Stackhawk. Gentlemen, I'm gonna turn my camera off, put myself on mute, and you can take it away.
Awesome, thank you, Sharon. I'm really excited to be here with Zach today, and just talking about pipeline security. And so a little bit about Zach and I. So I'm an evangelist. There we go. So I'm Ravi Lockman. I'm an evangelist at Harness, so I help build people with technology. My background, I've been a distributed systems engineer forever. I've had my fair share of incidents, and before Blameless Culture, I was blamed a lot. But Zachary, and for people who don't know who you are, maybe a little bit about yourself.
Sure. I'm a DevOps engineer at Stackhawk, been there for a couple of years almost. And I've been in the industry for some time too. Got started as, in IT and pretty quickly in the early days got into automation. And at that time it was systems automation and then through to application, delivery automation, such as is common today and what we're talking about today. And I'm excited to be here.
Cool, thank you. So what are we going to be talking about today? So we have kind of three themes that Zach and I are going to cover. So the first one is security, everyone's responsibility, question mark, exclamation mark, is it? Well, and quick answer is yes. We'll get into that, why is that? And then shifting left into DevSecOps, so this whole shift left movement, one of the pillars of DevSecOps, so Zach's going to kind of go through a little more in detail some of the pillars of DevSecOps and just how to get started. And then also something that Zach and I did together, we actually built a joint demo, so we can give you some more information about that. If you were building security into your CI/CD pipelines, what does it look like from an application integration standpoint? And also what is the physical pipeline, like what does security look like in those pipelines? So let's go ahead and get started. Security. So a very interesting thing over the last week here at my current employer, we actually went through IT security training. And so we had this like mandatory IT security training that we had to do for like one of our SOC 2 audits that we have. And from an engineering perspective, it's like any other corporate training that you have. It's like one of the slides for phishing. The CEO is here. Like, no, this is not the CEO sending me an email from a.att.net. He has the actual email address here, right? But basically, this is it, right? Like, hey, a lot of times, what they teach you, on the corporate side of things, doesn't necessarily translate to the application side of the house. Have a clean desk. Don't let someone follow you from the boat. Maybe not a modern example, someone following you behind at the door. But this is basically it, right? So security is everybody's responsibility, and also. Another joke here, like if a system can't communicate, it's secure, right? So a very secure system is one that no one can communicate with, but doesn't provide any value. But yes, security is everybody's responsibility. Now let's take a look at where we are, right? So as a software engineer, which one of these entities or people do you trust? Do you trust GitHub? Do you trust Docker? Do you trust FluentD? Do you trust Jenkins or do you trust Pickle Rick, right? And so very clearly we would, by process of elimination, you would say, well, I don't really trust Pickle Rick there, so let's close him out. But I'm not quite sure who to trust with these other entities. And the rationale behind this is that, the application is always trusted, right? And so with the application being always trusted is that, hey, in our software design or our software domain, there's this belief that the application is always trusted, right? Now, if you kind of fast forward to like modern thinking, there's this concept called zero trust, right? Nothing is trusted, or there's like mandatory security policies versus like, let's say, discretionary security policies, and you deny everything. But from a developer standpoint, imagine you're working on your local machine, right? You're building something. And so on your local machine, you clearly don't have the firewall between, let's say, if you have like an application node and a local copy of a database, maybe you have MySQL or a single node of Cassandra running. It's all right there, right? Like you're building a pre-authenticated environment, and because your belief is that, well, the application is always trusted, and so whatever security implements that you have locally is what you're dealing with, and so. Let's talk about how this looks, right? And like where there's like sort of like a disconnect. So this disconnect this paradigm that we're dealing in as a software engineer. So clearly, as a software engineer, so this picture of Rick here. So huge Rick and Morty fan if you can't tell. As a software engineer, I know that the end user doesn't have direct access to the database. So let's say our database is Cassandra here. So clearly, I'm building, when I'm building my feature or functionality, even though I might have direct access to it, I understand that no, the end user will never have end access to it because the application has to front it. And kind of like in the middle there is where you're operating as a software engineer, right? Excuse me. So you might be having a local version of Kubernetes. You might be having something like K3 or Minikube, or you have like some sort of segregated Kubernetes development integration environment or namespace dedicated to you. But in that case, like you're like, yeah, I'm operating like the app. I as software engineer is operating like the application because I need to communicate with the persistence layer. And so the end user is not authenticated, but the application is. And this is where the fall off usually occurs, right? It's like, oh, there's something in between that would prevent that. Here's where it comes to question mark. Like when transversing the entire user journey, let's say from the public internet to the persistence layer, you're actually going through a lot of things, right? You're like, for example, you're going here from the user, you're going through a load balancer, or actually that's a CDN, that's Route 53 to a web application firewall. That's kind of scrubbing and interrogating a user. It gets load balanced to a certain Kubernetes cluster, which is behind virtual private cloud that finally talks to Cassandra. But where's security in there, right? Like how can you mimic that environment on your local machine? It's impossible to do that, right? And this is where the information disconnect is. You're assuming that it's still secure, like, oh yes, someone had to have security. The security had to be there, because it's really reinforcing this point. Back in our domain, is that the application is always trusted, right? And so, how do we disseminate information that for example, proper security information, proper design consideration, proper application security information? How do we disseminate that to the end user, like the internal customers, which is the software engineering teams out there? And how do we bestow best practices? And this is where my buddy Zach is going to come in and talk about shifting left into DevSecOps and kind of give a definition of it. Zach, take it away.
Cool. Thank you, Robbie. I think that's a really great example and a great setup for why it's important to have good application security and why it's important to start integrating security into your DevOps practice, essentially. So we're going to shift left, and I'm going to describe how you can actually practically shift left and start adding some of these security controls into your pipeline. So first I want to define this term DevSecOps that you're seeing and you may be sick of, but we've been hearing it go around. And I think basically the idea with this is that we want to bring us a software development mentality to security, because back in the old days when DevOps became a thing, the reason it became a thing was because developers and operations were really separate departments, and they were often at odds with one another. And by bringing them together and having them basically work on the same team, we were able to get more of an engineering mentality into the operation. So you started to see more automation in the IT processes. You had developers getting more involved in getting their code to production. And so DevSecOps is really about doing the same thing for security, getting security people into an engineering frame of mind, and get getting developers into a security frame of mind. So I'm going to describe a couple practical ways we can do that. So one important thing is secrets. So anytime you're working on deployments of your software, of your application, you've got secrets that you need to take care of, that you need to keep secret. And one mistake that people can make is to add secrets to their Git repositories. And that can really be problematic because in Git, everything lasts forever. It's never going to go away. So it's important to keep any secrets that you have, such as passwords, security tokens, these sorts of things. Keep them out of your Git repository and keep them safe in some other store. And there's a lot of options for that. One such option that you may have heard of, it's pretty common in lots of different environments, is HashiCorp Vault. And it's this security software that's really just built around keeping secrets safe. I mean, in your browser, you may use 1Pass or LastPass, and it's sort of the same concept, but for server software or for application security. Other options these days, there's a lot of cloud point solutions. Harness has its own built-in secrets management solution. AWS has a solution. GitHub has a solution. Kubernetes itself that has a secrets facility built in. So it's important to use those. And a check that you can put into your pipelines today is to actually check your GitHub repositories or your Git repositories for secrets. There's a couple different tools for this. Things like Git leaks or Git secrets are both open source solutions. If you keep your code in GitHub, GitHub itself actually has a utility for secrets. It's called secret scanning, and it will go and look for common types of secrets that it can detect. Moving on from there, software composition analysis, or SCA, is a really common utility in pipelines today. It was one of the first because it was one of the easier things, and it was also a real danger and continues to be a real danger today when you look at pipeline security. And this is the idea that your dependencies might come with vulnerabilities built in. And so you see in the CVE database that there are tons and tons of new ones that come up all the time. So what SCA does is it will take a look at your dependency tree in your software. It's language dependent, but a good SCA utility typically knows how to find your dependencies that you're pulling into your software. And it just goes and crawls them, and it looks for the dependencies of those dependencies. And it goes and looks for any in that chain that have known vulnerabilities, and it will alert you to them. So the best of these utilities will not only alert you to them, they'll tell you exactly how to fix them, and in some cases might even offer to fix the problem for you at the click of a button. Some examples of this are Dependabot is a really common one, and that's built into GitHub. So if you have your code in GitHub today, it's really worthwhile to turn that on because it's actually, I believe they offer it for free for public and private repositories. So definitely worth turning that on if you haven't. Other options are Sneak, and which has a great solution. They sort of popularized SCA in pipelines. And for an open source solution, you can look at something called FOSSA, F-O-S-S-A. One of the advantages of SCA is that it's really, really fast. It's very simple, and it fixes things for you. But one of the cons is that it doesn't really tell you about problems that you have produced or security bugs that you might have produced in your application. And in fact, it might find bugs in dependencies that you never express in your application, so they aren't relative. Still, always good to go with the recommendations of your SCA. Next is static application security testing, or SAST. And this is a different method. So what this does, and some examples of this are CodeQL, which is a GitHub property. SonarQube and checkmarks are also options out there. And what SAST will do is it will actually take a look at your code. So it's language dependent. It takes a look at your code. It sort of compiles it into a database that it can search. And it runs queries against your code looking for patterns that would indicate vulnerabilities that you might have introduced into your code. And then it will tell you what those problems are. And one thing that's really good about a good SAST utility is it will tell you exactly what the problem is, which file it's in, and even what lines it is expressed in. So it makes it pretty simple to go and find the issue and deal with it. Some of the cons of SAST is that they do have false positives from time to time, and they can be a bit on the slow side. But you are starting to see this integrated into pipelines more and more. And then finally, we have dynamic application security testing, or DAST. And this is what my company Stackhawk does. Now there's lots of options out there for DAST utilities. Burp is one of the old players in the market. It's still a very common tool for penetration testing. There's OWASP ZAP, which is an open source solution. And actually the founder of the OWASP ZAP program is a distinguished engineer at Stackhawk. And Stackhawk takes ZAP, we've built our product around ZAP, added some enhancements, but mostly what we've done is added a platform that makes it really usable in pipelines. So it's very easy to introduce it into build pipelines and deployment pipelines to test your application. We also have a platform where we can gather data about the issues that it's found, so you can sort of track your application security over time, see how you're doing, and also manage issues that you find and triage them in different ways, such as accepting them or marking them false positive, but more often assigning them to developers and giving them tools that they can use to examine the issues and figure out the problems and resolve them. So what is DAST exactly? As opposed to SAST or SCA, it doesn't actually look at your code at all. It's language agnostic. Instead, what it does is you run your application and you scan it with a DAST scanner. And what that scanner does is sends in probes, requests to your API. It could be an open API application or GraphQL or SOAP application, or traditional web application. And as it probes it, it's looking for responses that would indicate vulnerabilities. And so the great advantage of this is that, of course, it's not language dependent. When it finds issues, they typically are real issues that would be expressed in production. And it can find issues that the other methods of scanning really can't find, because if you can't find a code pattern that indicates a scripting reflection attack or a SQL injection attack, DAST will just go and give it a try. And if it is able to succeed in its attempts, then it's going to mark it as a positive. And then you'll know that that's something that you need to address. One of the cons of DAST is that it can be a bit slow, but that depends on your application and the speed of your application itself. So those are some of the methods that you can use today to add security checks to your application security pipeline.
Cool, and thanks, Zach, and a lot of great information there. Oh, here an echo. Oh, there we go. So, sorry, Zach. He has very powerful speakers in his house there. I'm jealous of the speakers. So with those different types of toolings, like, I think we're going to split the next part about one, how do you integrate this tooling with your particular pipelines? But two, also, what about the pipelines themselves, right? If you kind of gander back to SolarWinds, if you're familiar with it, it was actually a pipeline-based attack that occurred. And so your pipelines, so kind of a two-part thing. One, your pipelines are designed to be an orchestrator between your ideas and production, right? And so, but come with the latter part of that, the production side of things, your pipelines have elevated privileges, right? Like they're doing the production deployment. So at some point, somewhere, it has to touch production. It's not going back to my very first slide with, if you turn the system off, it's very secure, right? Like, no, that's of no value to anybody. And so let's actually talk about your pipe, like the physical pipelines first, and then we'll talk about what does integration look like between hey, how do you build proper DevSecOps practices into your pipelines. So the first one is, well, when building a CI/CD pipeline, you should actually, this is per the prudence of the pipeline itself, is that hey, you should have quote unquote the bare necessities, as Mowgli and Baloo would say here. It's a concept of least privilege, right? And so basically the definition of concept or the definition of least privilege is a security terminology that is limiting access rights, right? And so least privilege would be that, let's say that Zach is the production engineer, release engineer, or DevOps engineer. He should have access to production, but myself as a developer, I should not have access to production. It's a very common business control. But you might say, hey, isn't the whole point of using CI/CD getting people out to production quicker? Of course. But you should limit my access as a direct, not a system-to-system access, but my direct access to it should be a good example is I need to go collect logs, right? And so I should be able to get read-only access to logs throughout the pipeline versus I don't have direct access to make a change in production, such as the pipeline itself or Zach as a production-facing engineer. And so the funny part about this, like without a pipeline, this would have been common sense, right? Like, oh yeah, we have business controls to separate the production environment from separate entities, or we as a developer, if you're dealing with a very, let's say, regulatory-based environment, if you're making a healthcare application, as a developer, you wouldn't have access to production logins for that privileged information. But those are common sense items. But when it comes to your actual pipeline, sometimes I've seen people forget that, hey, you should be implementing a least privileged model. It's like another application, your pipelines. Another thing to take into consideration here is that having role-based access, right? So how do you actually achieve the least privilege concept? Is by having role-based access. They say that dogs have masters and cats have staff, depending on dog versus cat argument here. But this going back to the same thing, I have a different role than Zach has, and Zach has a different role than me. And so by implementing the role-based access, that's one very good way of getting the least privilege type of model or zero trust model, depending on, zero trust takes that a step further, actually, depending on what side of the equation you come upon. Secrets. So the second time we're mentioning secrets here, right? So Zach mentioned secrets. I'll also mention secrets here. That it's very funny that it's as common sense as it sounds. It's actually something very easy to forget, because if you're the purveyor of your CI/CD pipelines, a lot of times you might be hard coding some configurations, right? Oh, you know what? I need to change environments. I need to SSH something, or I need to get, if you're using Kubernetes, I need to get kubectl access for the tool. The tool needs kubectl access, or you just have a role in Kubernetes that it can deploy to. Like, those items are sometimes hard coded, right? It's like, oh, no one's going to see it. Only the pipeline sees it. But hey, good sanitary use of what you would do off the pipeline, you should do on the pipeline, right? So this is like kind of a common theme. You have secrets that the application references. Your CI/CD pipeline should reference secrets. Don't hard code passwords, right? Especially as you're changing environments, you're laying up certain environmental variables for the application to pick on as it traverses your environments. Secrets are important. There's lots of secret managers out there, such as Vault, or even Harness has one, or pick your cloud provider. They have good secrets managers, and injecting those is crucial. And it can be difficult, right? Like, hey, it's some shell script somewhere had, a destination hard coded, or it had some sort of like obfuscated password. Hey, still put those things in secrets. Also, having the ability to, this is kind of now taking a step into the application now. And so having the ability to actually audit what you do is important. It's the quintessential, we need to find who broke it. Or this goes back to blameless culture I alluded to. I got blamed a lot. I mean, okay, it probably was me, but if we should say the engineer did something. It's just understanding what happened to totality. Like your database is if you use a relational database, your database is not just a point in time. It is a representation of all the adds, the deletes, the updates up until that time, right? So same thing for your software. Your software is a culmination of decisions that happen before your time on a project, during your time, and most likely, if you're not retiring the application, it will live on past your time on a particular project or team. And so understanding how and what and where a change occurred is important. It goes without saying, regulatory companies that are how to have regulatory compliance require this, but this actually could benefit everybody, like kind of seeing a change. Here I was making a change to a Kubernetes manifest. I gave it 1 more megabyte of memory just for show. But having a proper log of like, hey, at this time of day, Robbie made a change of this. And also in CI/CD, the kind of the common issue is that you might be dealing with more than one type of configuration. Here it's YAML, it can be Bash, it can be some proprietary format, it can be XML. And so just keeping track of what's changed, it's actually fairly easy for people to make changes on the fly. Again, how do you keep control of that? Now, this gets into a little bit more of the intrinsic part of the talk, is that security does start with you, right? It's like, hey, you know what? Security does start with you. No matter where you are in the organization, if you have to be subject to an hour-long training like I have about keeping a clean desk, I mean, it definitely steps into more than that. Application security, it takes multiple folks. There's AppSec engineers, there's network security, it touches every team. It eventually trickles into the application development team because that you were the ones building the software. And so security really does start with you, right? Just having this particular mindset that, you know what, any incremental improvement that we can make, either in time to getting this information and or making a more hygienic decision, is really crucial. This is where I'm going to invite Zach to come back on in a sec. But now we can talk a little bit about some of the cool examples. We have a screenshot of it here, but kind of laying the groundwork for this is that some of the tooling that was talked about from SAST or from SCA to SAST to DAST, those are all actually integratable into your pipelines, right? So Zach and I made an example here that we actually leveraged the Stackhawk tool to make a decision. And so if something was unhygienic, it would stop the pipeline. If it was hygienic, it would kind of continue on the pipeline. And so not only are we securing the pipeline, but we're disseminating information throughout. But kind of pose the question to Zach here. Maybe we can talk a little more about the example or even other types of integrations that you've seen, like what are some good practices?
Yeah, this is a great example. This is sort of a bread and butter approach because Harness, is really dedicated to, the classic Harness product is all about deployment and Stackhawk, and therefore it is particularly useful for DAST scanning because, as I mentioned before, a DAST scan requires that your application be up and running. And that's definitely possible to do in normal CI pipelines, but if you've got a dedicated deployment pipeline, such as you can implement with Harness, it's really ideal. So in this example, we created a development environment within the Kubernetes cluster to deploy the application, and you could deploy any dependencies along with it so that you can really get a full end-to-end test, scan that sucker with Stackhawk, and get the reports back to the dashboard, which you can see a little preview here of down in the bottom of the screen. So it really was an ideal environment for running an application or a DAST utility like Stackhawk.
Yeah, awesome. And with that, right, like kind of one of the, there's no limitation here also, right? Like you can run multiple tools, kind of a common pattern that I've seen, and I'm fortunate to talk to a lot of our customers here at Harness. So we focus on your CI/CD pipeline. Is that in lower environments they actually start out with SCA and SAST, right? And so before the application's built, they're doing hygienic checks that it's quicker for us to remediate a version of, let's say, I don't know, like Spring, some sort of Spring library, right, or Spring security. Like they're able to remediate that early before they go through the build process. But again, that's I call this the fog of development, right? No one person has the entire purview, and so there's this item called compensated controls. So we haven't brought that particular. Actually, I did with the RIC and all these WAF and all that load balancer stuff. Is that you're assuming that there's some sort of compensated control, right? And so if I go back in time to my favorite slide, keep on going. There we go. Here we go. Yeah. So that bottom slide there. Where a lot of like the information gap is that I'm assuming that there's a compensated control, but I can't really test it. And this is where DAST actually comes in. So the DAST tool will actually go and test it, right? So it's running your application. So whatever controls it has in the application or the environment, if the DAST tool is unsuccessful, it's going to come back with a clean bill of health. Versus if it's not successful, my assumption that all these compensating controls around it were working is not. And that's a lot of powerful information, right? Like you're making hygienic choices very quickly early on, and then also you're as a sanity check, where that big gap is coming from, a DAST tool would step into place.
Yeah, and an important thing about bringing this security into the pipeline and having it happen every time a developer checks in code is that, think about the old way that this was all done. In the old days, and still today in a lot of companies, there's maybe one pen test a year, if that, or maybe a couple if you're lucky. And then what you get from a penetration test is, hey, I was able to get through your application security, and here are the ways that I did it, and here are the problems that I identified. And what you end up with is this gigantic PDF report that your security people can understand and look at, but then they have to delegate that out to developers to work on. And that's a really bad cycle time once a year, maybe 2 times a year. And also, it doesn't get developers sort of into the day-to-day of understanding security, understanding issues as they come up, and being prompted to work on them and giving them the tools that they need to see them as they come up and handle them as they come up.
Yeah, perfect. Look, I think there's this kind of ends the formal discussion that Zach and I would have, and so we can definitely have an off the cuff discussion if anybody wants. But Sharon, it looks like there's a couple of questions that are coming in through the chat, so we can answer those now, Zach, if you're okay with that.
Yeah.
Awesome. All right. So here's one. This one's for Ravi. Is it possible to integrate Harness with CyberArk, AIM, AAM, DAP to manage hard-coded credentials?
Yeah, so Harness integrates with CyberArk Security Manager. So, yep. Easy answer, yes.
Awesome. All right. And actually, another audience member had also mentioned CyberArk when you were talking about those tools and solutions earlier, and I am getting a spam call right now, so I apologize.
Popular.
Just going to delete that. All right, so moving right along, what are some popular attack vectors that you see in pipelines?
These are harder questions now.
I know.
The CyberArk.
I threw you the softball first, and you hit it out of the park. So
I'll take a first stab at this, Zach. So your entire pipeline is vulnerable. End of story, right? It's a piece of application, it's a piece of infrastructure that is privileged, and so it's a 2-part journey. That as CI/CD becomes more popular, so does it as an attack vector. The old adage that your Mac never used to have a virus because they weren't popular. Now all of them are targeted against your Mac, right? Which as technology becomes more popular, as it becomes more ubiquitous, it's an easier attack surface, right? The same thing for Kubernetes. As it's becoming ubiquitous in enterprises, it's actually easier for an attacker to attack it because they can have an exact replica of Kubernetes, without paying for it, right? They can, disseminate that across. Again, popular. So it's kind of 2 parts. One is your application and application infrastructure are very common attack vectors. In fact, they're probably the most common attack vector now, right? Going back to the application is always trusted. In terms of CI/CD, SolarWinds is an example kind of that. It wasn't necessarily the pipeline caused it, but it was more of was some checksum there. It could be an argument. Was it the repository? Was it the manufacturer of it? Was it the person who did the pipeline? There wasn't one answer, because if it was, it would be easy to never let that happen, right, in the first place. So I know a long-winded answer, but anything can be attacked, right? And getting first is locking down your pipeline. The second is disseminating the information to make your applications more secure. Is very important. So.
Yeah. Awesome. Yeah, I agree with everything that you just said, Ravi, and I think you really covered it well in your final section of the discussion, as well as all these things that you need to do to protect access to the pipeline. use all the common methods that you would use for any other thing that you hold dear. Multi-factor authentication, super important if you've got a cloud-based system for deploying your software. And speaking of supply chain attacks, definitely SCA is a very helpful thing, because that's where a lot of vulnerabilities can be introduced. There are definitely nefarious attackers who will find an orphaned common library that many people use in their own utilities or in their own software supply chain to introduce vulnerabilities into your applications that you wouldn't necessarily know about. And if they're really crafty, they'll find something that you don't directly link to as a dependency, but they know it's a downstream dependency of some other dependencies that are commonly pulled into applications. Yeah. Also think about when a lot of times when people are using GitOps, they'll want to run some checks on software when somebody issues a PR, and you might accept PRs from public contributors as well. Be careful about what kind of routines you run on a pull request to your repository, and make sure that you're injecting some vulnerabilities that many people could have access to if they were clever about it.
What about IAST?
Oh, like IAST?
Yes.
Interactive application security testing?
That's the one. At
Yes.
least I'm going to assume. Joseph, I hope that's what your question was referring to.
That is an excellent technology, extremely useful. I'd say using an interactive technique for looking for issues with your software is a good thing to do. It's probably hard to automate, although I'm sure somebody can correct me on that if I'm not correct about it. But I would look at that as a utility for more exploratory ventures into your application security, like maybe run that alongside a fuzzer to look for inputs you aren't expecting, and just trying to dig a little bit deeper and take time to do manual testing.
And there's another technology too, like just taking that a step further. There's one called a RASP, RASP, a runtime application security platform. But RASP can get very complicated because they actually are included as a binary in your application, right? So like, for example, a Java RASP would actually intercept all method invocations, right? So it's geared towards like 0-day type of attacks. Like you can, the RASP would communicate to a third party, to a vendor service to update its, virus scan, whatever, lack of the proper term for it, its definitions, ever so often. But then it's actually embedded in your application. But that has pros and cons, because it can there's overhead. Nothing is free, right? If you have to intercept every method invocation, trust me, there's going to be some overhead there. But it is one way of preventing, like in 0-day. Let's say there was no active development on your application 5 years from now, but it had a RASP installed. Potentially it can prevent itself. And lastly, a little more of an intrinsic answer is that even with these particular, like let's say with a RASP, or even if your tooling shows something, like those are only patches, right? Like it's up to the engineering team to make the fix. If your DAST tool said something is insecure, compensating controls and engineering have to take a look at it. So like similar to a RASP, it's just a Band-Aid. Well, DAST or information providing. A RASP is actually functionality that will intercept stuff. So hey, don't just rely on it. Is my main advice.
And think of the implications of I'm not trying to throw too much shade on RASP, but think of the implications of a false positive in your RASP implementation. If it thinks something is an attack, but it's actually somebody that's trying to send you $1,000, that's not good.
Throw all the shade, sir.
I was going to ask, I guess, what's the balance between the effort and energy and cost of having someone or someone's have to chase down all the potential false positives versus, what Ravi was talking about, where there are certain things that that are like intrinsic in the app that just shouldn't get rectified. I don't know if I'm making any sense.
Yeah, essentially, what's the cost of doing all of this?
Right.
Like, what's the
There you
cost of
go.
integrating this into your practice? And it is a trade-off, and different companies will come down in different ways. But my impression is that it's really a trade-off in, are you willing to do the upfront effort that it takes to get this into your pipelines, to begin doing this practice? Because to maintain them really isn't that bad. All of these different methods. Part of the beauty of them is that if they're automated, it sort of sustains itself, and you're getting, you're developing in small batches, hopefully, and you're releasing daily or frequently. And at the same time, you're getting this feedback just as frequently. And the problems that you see come up are going to be small, because it's going to catch one little bug as it comes up, as it is introduced into your AppSec build pipeline, and you can address it typically pretty quickly.
Gotcha. Instead of waiting until it's got 75,000 dependencies and then gets pushed to production, and then you're fixing much bigger problems, right?
Yeah, the cost at that point is astronomical. Whereas if you can fix this problem, ideally in the development cycle, as you're building, as you're working on it in your IDE, locally on your workstation as a developer, that's the best place to catch these things. Then it's pretty cost effective to fix.
Joseph has a follow-up question here. He's asking, doesn't Rasp require that you put agents in your application? And if so, any tips?
Yeah, it's an installation. It's a dependency. So like, if you're writing a Java application and you're using Maven, it's another line of your Maven config in your POM. It's like, rasp.hp, pick on HP, but like some com.hp.rasp dependency, and you have to wire in your licensing information. So, I mean, tips would be the same. It's like you're introducing an APM agent or a dependency, right? Like it actively takes the development team, because sometimes, to Zach's example, you don't really know how it's going to interact, right? Like, you need to test it out, right? And you need to vet it, and not all applications are good candidates for it. So there's no way around you testing it and just benchmarking what your performance was before the Rasp, and benchmarking what the performance would be after the Rasp, and compare those deltas.
Okay. So this is a pretty broad question. How does an open source software pipeline shift left without an IT team to monitor the application? What does that operations team look like?
I can take it. You can take it.
Yeah, that's a complicated question with a lot of different answers, probably. I mean, at some point you have to operate the software. You've got to get it into production and up and running, right? It's just sort of how you take that approach. If you mean like a traditional IT team, then you're probably already making that move to start shifting left, right? How would you answer this, Robbie?
Yeah. I'm just taking another pass at the question there. I interpret it a little bit differently. So I'll take a intrinsic answer. So if I read it as, if you're leveraging open source, there's no development team left. Like, how do you maintain that? Congratulations. If you're leveraging open source, you are now the software vendor, right? So either I'm sorry or congratulations. You're the software vendor to your customers. So they don't care where the software came from. They care about their experience. But if you're leveraging a lot of open source, which most of us are, right, that you become the software vendor to your customer. A little bit of a background story. When I was in university, I was a contractor for a credit bureau here in the greater Atlanta area. I leveraged struts in my application. Just fast forward to 2017, it was the same team, right? And so even with active development, they didn't catch it, and so it's difficult, right? One thing is you have to get, this is going to be a generic answer, you have to get your hand around the problem, right? So I'm not sure your particular role in your organization, so I'm just going to make an assumption. Maybe that you're a cloud architect or system architect, right? One thing would be just, you need to scan everything, right? Implementing it in some of your applications might be so old that it doesn't make sense in a CI/CD pipeline. Using a DAST like Stackhawk or even a binary scanner would be in your best interest to start building the corpus of. We have 50 apps, 45 of them were green, 2 of them were yellow, and 3 were red. And if then once you determine what needs to take action on, you can take priority over. Hey, we need to find someone to make modifications to the application. This is an extreme enterprise risk, and just take action, right? So going and finding the right resources, either be a contractor or another team, to make those changes. So, but yeah, generically, you need to wrap your hand around the problem.
Yeah. I'm sorry. I think I misunderstood the question, and that's a great answer. There are a lot of people. One of the problems with an open source project like that is finding all the right contributors to your project, and also vetting changes that come in from the public. And so, it's really as important as any other project, maybe even more so in some ways, to set up these controls in your build pipeline and in your delivery pipeline for an open source project, to help you save time in checking changes that come in. So yeah, it's important to set up. And most of these tools that we've talked about today, there are free options or cheap options, and often free options for open source software as well. So every tool that, every class of tool that I've talked about, there are free or very cheap solutions to the problem.
All right, let's see what else we've got here. First of all, thanks, folks. This is great. Keep sending those questions in if you've got them. We will keep going as long as we can. What about, actually, that's a great segue, Zach, because I think we have a question about what are some good free tools to get started with this.
Yeah, so Stackhawk is free for developers. We do have a free option, and for open source software. Of course, OWASP Zap is an open source, is the open source scanner that we're based on. There's FOSSA for SCA. There's Dependabot. GitHub has several options that are free especially for open source and public projects that you can look into. So GitHub has CodeQL for SAST, and they have Dependabot for SCA. So right there, you've got a decent tool chain that walks through most of those issues. In fact, GitHub even has secrets scanning technology.
Yeah, they'll tell you if you use a secret. Because sometimes I'd make example pipelines, and I'm like, no one's gonna, this environment's gonna be destroyed as soon second I'm done with this demo. They're I get these nasty gram emails. You have sensitive information in your configuration from GitHub.
In fact, I think they turn on, by default, they turn on their SCA Dependabot for public repositories. So you'll just start getting alerts. Hey, you got some dependency problems? You should hit OK on this to fix that.
Yeah. All right, folks. Well, thank you so much for all the great questions. And thank you, Ravi and Zach, for that amazing discussion. Just a reminder to the audience that the session has been recorded. So if you want to go back and watch it again, please feel free to do so. We will send you an email with instructions for accessing the webinar on demand, or you can always visit us at devops.com/webinars. It will be there for you as well. All right, so now it is the moment we have all been waiting for. We are going to choose the winners of our Amazon gift card drawing. And our first winner is Tabiso M. My apologies if I did not pronounce that correctly. Our second winner is Mathi R. Again, apologies for my pronunciation. Diane D is our third winner. And Trisha P. Congratulations to all our Amazon gift card winners. We will send you an email with the instructions for claiming your gift card. So keep an eye on your inbox. And if you don't see it there, please make sure and check your spam folders. Well, that does it for me. My name is Sharon Florentine. Thank you again, Ravi. Thanks, Zach. We hope to see each and every one of you again soon on another DevOps.com webinar. That's it for me. I'm signing off.
Bye, y'all.
Thanks, Sharon. Thanks, Ravi.
Thanks, everybody.
Take care.